Hi, I'm John LaRue, author of the book Wave Goodbye, Simple Tsunami Mitigation. As you know, the Indian Ocean tsunami made December 26, 2004 the deadliest day in history. I believe a little planning and 20 minutes of warning could have prevented this tragedy. First, let's take a look at this wave. A wave is just energy through the water. The wave can move forward while the water stays put. If the yellow dot represents a liter of water on the surface of the wave, it will more or less be in the same position every crest of the wave, or for that matter, every trough. When the highlighted liter moves from trough to crest, the wave is lifting it. When it moves from crest to trough, its mass is propelling the wave. This means practically no energy is lost as the wave travels by. The tsunami wave contains energy from seafloor to surface. At 2,000 meters of depth, the wavelength is 151 kilometers. That means that 75.5 kilometers of wave are pushing water into a crest, and the other 75.5 kilometers are falling into a trough. So how much energy is being carried by a 10-meter tall wave over a kilometer of shoreline? Enough to lift a wave of water 10 meters. It would take 37.1 million cubic meters of energy to 70% fill a box, one half a wavelength, 10 meters tall and 1,000 meters wide. Since the tsunami wave pushes water up for 9 minutes, there are just under 69,000 cubic meters of energy flowing forward per second. If we could reduce that energy by 10%, we could turn a 10-meter tsunami into a 9-meter wave. Let's talk about how you could do as much with bubbles. Now let's bring some bubbles to the rescue. If you took a single cubic centimeter bubble and started sending it toward the surface, it would be displaced by 42 cubic centimeters of water on its way up. That 42-to-1 displacement is for the very first second of the bubble's journey to the surface. After that, the bubble would start moving faster and get larger, making that multiple even greater. There are an infinite number of combinations of gas bubble size, depths, and amounts that can stop a tsunami. Here's one. 62 cubic meters of air deposited at 250 meters of depth and formed into small bubbles will shrink the first second of a wave by 10%. Every second this wave passes this rising column of bubbles will shrink the diameter of the rotation of water that is carrying the wave. By the time the air reaches the surface, the energy of the tsunami will have been completely absorbed. Like all waves, a tsunami is moved forward by rotating water. The surface water moves one cycle every 18 minutes. It's 20 meters in diameter in a 10-meter wave and is supported by water rotating all the way to the seafloor. If a tsunami wave is a sine curve, hundreds of kilometers in length, with 10 meters of amplitude, putting air into the supporting structure is like putting sand in an auto transmission. If you'd prefer that in the future all of your tsunami waves look like this once they get to the beach, please keep in mind all you have to do is put a little bit of air into the water, into the wave, and you'll be fine. If you need to know any of my math, please contact me at my email address, tsunamiwavestopper@gmail.com, or check out my website. tsunamimitigation.com. I'll happily discuss with anyone making tsunamis and storm surges a thing of the past.